Hey, so in next couple of videos, we are going to discuss how integers and character get stored in the memory. So this is going to be very interesting. See, these videos are kind of advanced because they are not directly linked with programming or they are not directly linked with C++. This is a very general concept which gets followed in all the programming languages. But as a good programmer, you should always know what happens when you create a variable, how the data is getting stored internally in the memory. That's very interesting and very important to know. And as a pseudo programmer, see, pseudo programmer means a super programmer who has a good idea about all things, how things are working internally. So as a pseudo programmer, you should always know things like how things are getting stored in the memory, how integers are getting stored, how characters are getting stored. Let's start with some numbers. So what I'll do is, so we have to first convert positive decimal to binary. So let's take some number. Let's take 10. See, this 10 is in decimal right now and it's a positive number. What we have to do is we have to convert this 10 into a binary number. We have to get binary equivalent of this number. So the method for converting positive number into binary, positive decimal into binary is very easy. What you have to do is you have to follow this method. I'll just tell you what you have to do. See, write 10 over here. Okay. And then start dividing 10 by 2. See, why we are dividing 10 by 2 is because binary has base as 2. So we'll start dividing 10 or any number that you want to convert into binary but with 2. So divide it by 2. So once you divide 10 with 2, the quotient that you are going to get is 5 and the remainder that you are going to get is 0. So just write remainder over here and quotient over here. And just keep repeating this process until and unless your quotient becomes 0. So divide 5 by 2. So what is the quotient after dividing 5 by 2? So the quotient is 2 and the remainder is 1. See, over here we are doing whole division. We are not dealing with fractions. So I'm not writing like division of 5 and 2 is 2.5 over here and remainder is 0, because then in that case remainder will always be 0. See, we are dealing in whole division. So after dividing 5 by 2, we are getting 2 as a quotient and 1 as a remainder. Keep repeating this process. Divide 2 by 2. So we are getting quotient as 1 and remainder as 0. Divide 1 by 2. So once you divide 1 by 2, you will get quotient as 0 and remainder as 1. Once your quotient is 0, you have to stop. Now you have got remainders over here of division. What you have to do is you have to travel them from bottom to top, and this is going to be your binary equivalent of 10. So just I'll just write it from bottom to top. So the first number is 1, then I have 0, then again I have 1, and then I have 0. So 1010 is a binary equivalent of 10. Let's try one more number. Let's try a big number this time. Let's try 29. Okay, so 29 in decimal. Let's try to convert it into binary. So we'll have to follow the same process. I'll write 29 over here. I'll make 3 columns. Okay, let's try dividing with 2. So 29 divided by 2, what is going to be the quotient? The quotient is going to be 14. 14 2s are 28 and 1 will go as remainder. Then divide this 14 by 2. So after dividing 14 by 2, you will get 7 as a quotient and 0 will be the remainder. Divide 7 by 2. So you will get 3 as a quotient and 1 will go as a remainder. Then divide 3 by 2. You will get 1 as quotient and 1 as remainder. 2 ones are 2 and 1 is getting left as remainder. Divide this 1 by 2. So you will get 0 as quotient and 1 as remainder. Now write this from bottom to top. So it's 1 1 1 0 1. So 1 1 0 1. That's it. It's a pretty simple method. It's very easy to convert any decimal number into binary if it is a positive decimal number. Okay, now let me quickly clear the board and let's try with some more big number. Okay, so let's try with a bigger number. So let's try with 259. Okay, it's in decimal right now. We'll have to convert it into binary. So let's see what is the binary equivalent of 259. So again, we have to repeat the same process. Let's create 3 columns. So let's try dividing 259 with 2. So 2 ones are 2, 2 twos are 4, then 1 over here, then 2 nines are 18 and 1 will go as remainder. Okay, so 129 twos are I guess 258 and 1 is the remainder. Then again divide 129 with 2. So we'll get quotient as 64. 64 twos are 128 and the remainder will be 1. Now divide 64 by 2. 64, once you divide 64 by 2, you will get quotient as 32 and you will get remainder as 0. Divide 32 by 2, so you will get quotient as 16 and remainder as 0. Then divide 16 by 2, you will get quotient as 8 and remainder as 0. Divide 8 by 2, you will get quotient as 4 and remainder as 0. Divide 4 by 2, you will get quotient as 2 and remainder as 0. I'll just continue over here on the left hand side, sorry, on the right hand side. Divide 2 by 2, so once you divide 2 by 2, you will get quotient as 1 and remainder as 0. And finally divide this 1 by 2, you will get quotient as 0 and remainder as 1. So finally, once you write this number from bottom to top, the number that you are going to get is 1 followed by 0 followed by triple or 5 times 0, 1 2 3 4 5. So 1 2 3 4 5 followed by 1 1 followed by, I'll write 1 1 over here.